Welcome back. What we want to do now is find a formula for the directional derivative of f. So let's let f be a function of three variables and let p be a fixed point in the three space. And x0, y0, z0, those are the coordinates of p. Let's let u be a fixed unit vector, and let's let L be the straight line passing through P parallel to the vector u. An arbitrary point on the line L will be equal to P plus a scalar multiple of u. So here T is a scalar. So let out of T be P plus TU. So out of T is an arbitrary point on the line. So out of T is a vector function, and each point on the line is the value of R at some input T. Now R prime of T, because P is fixed and U is a fixed vector here, R prime of T would be equal to U. And notice that out of 0 is, so when T is 0 we get P, so out of 0 is P. And out of H would be P plus H times U. So what we are going to do now is we are going to calculate the derivative of f of out of T. We're going to calculate the derivative of f of out of T with respect to T when T is 0. And we're going to calculate this derivative in two different ways. Okay, so first of all, I'm going to let g of t to denote f of out of t. Then notice that g prime of 0 would be this derivative. So this derivative is exactly g prime of 0. Now g prime of 0 is the limit as h goes to 0 of g of 0 plus h minus g of 0 over h. Now g of 0 plus h is the same as g of h, and g of h would be f of out of h. So g of h is f of out of h, and g of 0 would be f of out of 0. Now recall that out of 0 is p, and out of h is p plus hu. So we get f of out of h would be f of p plus hu, f of out of 0 would be f of p. So notice that this limit is exactly the directional derivative of f in the direction of u at the point P. Okay, so we find that g prime of 0 is equal to the directional derivative of f at P in the direction of u. Now on the other hand, we can calculate this derivative by using the chain rule. By the chain rule, this derivative would be the gradient of f evaluated at out of t dot product with r prime of t, and then we need to evaluate that when t is 0. Well, recall that r prime of t is u. So if we plug that in, we get the gradient of f at p. So when t is 0, right, out of 0 is p. So we get gradient of f evaluated at p dot product with r prime, which is u. So we have calculated the directional derivative of f of out of t with respect to t when t is 0 in two different ways. In one way, we obtained that this derivative is equal to the directional derivative of f in the direction of u at the point P. In the second way, we obtained that this derivative is equal to the gradient of f at P dot product with u. Hence, these two quantities are equal, so what we have found is that the directional derivative of f in the direction of u at the point P is equal to the gradient of f dot product with u. Okay, so we have found this nice formula for the directional derivative. All right, so I'm going to stop here, and in the next video we will compute the directional derivatives of some given functions by using this formula.